In this video, I want to look at some alternative factoring methods, or at least the primary one, and compare that to the FOIL method that we've been using. I also want to point out that when you use the FOIL method, you do not have to fully write out all of the different possibilities and check them to see if one of them works. You can try the different possibilities just looking at these different factors and find the one that you think is most likely to work, and then plug into the binomials and check. Remember that the factors of the first term, or the leading term in our trinomial, go in the first positions, and the factors of the last term in the trinomial go in the last positions of our binomials. When we combine the products of the inner terms and the outer terms to get the middle term in the trinomial, notice that in the product of the inner terms, we have one factor from the second set and one factor from the first set, and also in the product of the outer terms, we have one factor from the second set and one factor from the first set. So we can check these just by looking at these factors right here without having to write them out fully. In this particular combination, we're looking at the products 2x times 3, or 6x, and 2x times 5, or 10x. And with the difference of 10x and 6x, we can either get a positive 4x or a negative 4x. So this combination will not work for this trinomial. And we could change the order of the pair of factors, just like we could change the order of the 3 and the 5 here. But with the 2x and the 2x, it will make a difference because these are the same. So the 3 and the 5 will not work with the 2x and the 2x. So now we could try the 1 and the 15. Now we have 2x times 1, which is 2x, and 2x times 15, which is 30x. And the difference between 30x and 2x is either going to be 28x or negative 28x. Again, this combination won't work for this trinomial. Switching the order of the 1 and the 15 won't make a difference because these first two factors are the same. That means that none of the pairs of factors for the last term work with the 2x and the 2x. So we're done with this pair, and now we can move to 4x and 1x. I'm going to change up the order here on this one, just to show that you can do that. And here, with the 3 and the 5 being different, and the 4x and the 1x being different, the order will matter. So with this particular combination, I'm multiplying 4x times 5, which is 20x. That would correspond to having the 4x here and the 5 here. And the x times 3, which is 3x. The 3 would go here, and the x would go here. With the opposite signs, we get a difference between 20x and 3x, and that will either be positive 17x or negative 17x, so that combination does not work. Now let's switch the order. 4x times 3 is 12x, and x times 5 is 5x. With opposite signs, we get the difference between 12x and 5x, and that can either be positive 7x or negative 7x. So we found the combination that we want, and now we can plug those into the binomial and check. I'll start with the 4x and the x. Those will go in the first positions. And the 3 and the 5 will have to go in the last positions. But remember here, we multiplied the 4x times 3. So if I have the 4x here in my binomials, I need the 3 to be here in the other outer position. And since I'm multiplying the x times 5, I'll need the 5 here at the other inner position. That gives us the two products that we had here. It's not a big deal if you accidentally put them in the wrong order, because when you check, it should be obvious and you just switch them. In this case, we want a positive 7x, which means we'll want a positive 12x and a negative 5x. And that means we'll need a 4x times a positive 3 and a negative 5 times x. And now we have the trinomial factored. With a little practice, you can check these combinations pretty quickly and come up with the right combination. And of course, if none of these combinations work to give you the correct middle term, then the trinomial is not factorable. Let's compare this to the most popular alternative method. This method is usually called the AC method. Here we label the coefficients of the trinomial A, B, and C. A is the coefficient of x squared, B is the coefficient of x, and C is the constant term. So in this example, A is equal to positive 4, B is equal to positive 7, and C is equal to negative 15. Once we've identified the values of A, B, and C, we compute the product A times C, that's where the name comes from, and we list all of the pairs of factors for this value. Here, A times C is 4 times negative 15, which is negative 60. And I've listed here all of the pairs of factors that have a product equal to 60. Since this is negative 60, these pairs will have to have opposite signs. Now, we want to find the pair of factors that has a sum equal to B, the coefficient of the middle term. Here, when we take the sum, since the factors in each of these pairs will have opposite signs, we'll really be looking at the difference. And as you go through this list, the pair of factors that has a difference equal to 7 will be 12 and 5. We want a positive 12 and a negative 5 so that we get a sum equal to positive 7 and a product equal to negative 60. A lot of people like to write this up in a diamond-shaped diagram. They put the product A times C in the top and the value of B in the bottom, and then they'll try different factors of negative 60 in the left and the right until they find one that has a sum equal to this value of B. But this is exactly what we just did here. Now that we found the pair of factors that we want, we can go on to the last step. Now we're going to split the middle term in our trinomial, b times x, into a sum given by the corresponding pair of factors. And then we can finish by factoring by grouping. So in this example, we're going to rewrite 7x as negative 5x plus 12x. The order won't matter here. You could put the 12x first and the negative 5x second. Either way, we now have 4 terms, and we're going to factor this by grouping. In our first group, we want to factor out the greatest common factor. 4 and 5 have no common factors, so the greatest common factor will just be x. And factoring out the x, we're left with 4x minus 5 in the parentheses. In the second group, we get a common factor of 3 between the 12 and the 15, and there is no common factor for the variable because we don't have one in the last term. And factoring out the 3, we're left with a 4x minus 5 inside the parentheses. Notice that the 4x minus 5 is the same in both of these groups, so now we can factor out the 4x minus 5 as a common factor. Factoring out the 4x minus 5, we're left with the x plus 3. The order of these two factors doesn't matter. And of course, you should check this by using FOIL to make sure you get the original trinomial back. This makes a nice application for grouping. And notice that when we split up the middle term using the pair of factors that we found, we get the terms from the inner product and the outer product from FOIL. And then we work backwards using grouping to come up with the two binomials. Most people use a diagram for this step as well. It's called the box method. You put the first term of the trinomial, 4x squared, in the upper left corner, and the last term, negative 15, in the lower right corner. In the other two corners, we put the two terms that we got when we split up the middle term using our pair of factors. So if you were using the diamond method here, once you found the pair of factors that gives you the correct sum, you use those as a coefficient of x to put in the remaining two boxes. So 12x from this factor and negative 5x from this factor. And it won't matter what order you put these in, just like it won't matter what order you write the two terms in here if you're using grouping. To finish this, we factor out the greatest common factor of each row. The greatest common factor of 4x squared and 12x is 4x. And the greatest common factor of negative 5x and negative 15 is negative 5. And divide each of these terms by that common factor and put the quotient here above. 4x squared divided by 4x is equal to x, and 12x divided by 4x is equal to 3. Notice that negative 5x divided by negative 5 is also equal to x, and negative 15 divided by negative 5 is also equal to positive 3. You could also have factored out the greatest common factor of each column. The greatest common factor of negative 5x and 4x squared is x, and the greatest common factor of negative 15 and 12x is 3. This is the same thing as factoring out the greatest common factors here when we use grouping. If we switch the order on these two terms, that would be like switching the order here within this box. Notice that this gives us both of the terms for our binomials. 4x minus 5 is the first binomial, and x plus 3 is the second binomial. So a lot of people do find it easier to use this box method than grouping, but I do think it's important to understand how to factor by grouping. And in these kind of examples, the factoring by grouping is not difficult. Here's a comparison of our FOIL method with the AC method. You can use any one of these methods. Whichever one makes the most sense to you is fine. Just make sure you show your work. Show how you come up with the two binomial factors. Notice also that for some values of the product A times C, you can have a long list of possible factors that you need to check. When you use the FOIL method, you're taking the factors of A and C separately, and then you're looking at multiplying those together in different combinations. So sometimes this can actually be a little bit easier. Notice every possible combination that I can come up with here from these two sets of factors will give me the different pairs of factors from the AC method. X times 1 and 4x times 15 gives me the 1 and the 60. 2x times 1 and 2x times 15 gives me the 2 and the 30, and so on. So the methods aren't really as different as they might seem at first.